We are joined here by Camilla, who's going to show us how fast and how good these point clouds can be created by the Zivid 2+R cameras.
I am super excited to show off our new amazing cameras. So my job is to write software that gets the most out of our cameras, and the hardware in the 2+R has really sparked innovation and opened a lot of doors to the vision team. Today I want to start out with showing you this bin right here, which is filled with random consumer products that you could find in a fulfillment center. So you have some transparent, some translucent, some shiny metallic stuff, a bit of everything.
Yeah, so this would be for piece picking, right?
Yeah, you're absolutely right, David. Up here I have mounted the Zivid 2 Plus MR130, and I'm going to show you what the 2D image on point cloud looks like in Zivid Studio. So as I said, we have a bit of everything in this bin, and if you go into 3D, you can see that we have these transparent surfaces that are resolved nicely without ghost planes or collapses. We have this shiny metallic wrapping right here without any reflection artifacts. Over here we have some bubble wrap, which is typically very noisy, but this is resolved nicely and smoothly.
So these point clouds look really amazing, right? You got these apparel inside plastic bags and transparent bottles and lunch boxes and whatnot. And obviously these surfaces are totally pickable for a robot. But what about the capture time?
Let's recapture and see. So the capture time now is about 150 milliseconds. So with the Zivid 2 Plus, this was about 450 milliseconds. So we are 3 times faster than before. That means that this camera can see everything that's inside a fulfillment center in record time, even if the robot has never seen any of this before.
So we're not going to limit the speed of the robot, and we're not going to limit the kind of inventory that it's going to be presented with or look at, which basically means that at the end of the day, with this camera, these robots are going to work faster, they're going to be more capable, and they're going to be more productive.
You're absolutely right, David.
Super cool. Let's move over to an application that works even faster. Let's go to parcel handling, where they do induction and sorting. So those guys, they need to pick at rates of 1,000 to 2,000 picks per hour, which is almost like 1.5 seconds per pick. So what do we got in store for those guys?
The Zivid 2 Plus-R is actually able to capture in sub 50 milliseconds, which will definitely let you do 1 pick per second. In parcel handling, it's easy to think that that's simple because it's just parcels. But as I will demonstrate with this scene here, we actually have a bit of everything there as well. So I brought some cardboard, some white packages, and some of these shiny black materials, which are really, really hard to get. So not only do you have to capture in a very limited time, but your camera needs to have an impressive dynamic range. I'm going to demonstrate this to you now, again with the MR130.
Okay, let's have a look.
So as we see, we are again able to resolve all these surfaces nicely and continuously, and we do so in only 40 milliseconds.
40 milliseconds, that's pretty incredible. So these robots are certainly going to be able to pick really, really fast. So for parcel handling, we can then deal with any kind of parcel, and for piece picking, we can deal with kind of almost any kind of inventory, do it at the speeds that they need to do. Let's move to the other side of the application spectrum. Let's go to manufacturing and look at what we can do for those guys over there.
Yeah, manufacturing is quite different with different challenges, but I think those customers will also be excited about the 2 Plus-R. So on the production line, it's all about precise execution. If the camera is not able to provide the precise location and size and shape of objects that it's seeing, the robot is going to fail. Therefore, I have brought this bin here to illustrate what the MR60 can do in a manufacturing setting. So here we have some very shiny materials. We have these metallic cylinders. They're a classic benchmark in 3D imaging. You often get these specular highlights on top that causes contrast distortion artifacts, which are very nasty. And we also have some other metallic parts that you will see in the point cloud.
So what do you have here, Camilla?
So to a 3D camera, this is a very challenging scenario as the light will be bouncing all around the place. When we look at the point cloud, we see that the MR60 is able to resolve all these objects very correctly. We get a lot of correct points on top of the cylinders and on the other metallic objects without any artifacts. The reason this is so important is that in manufacturing, you often want to do CAD matching. And the better your point cloud is, the more you can tighten in your positions in your CAD matching algorithm, giving fewer false matches and letting you have fewer missed objects.
All right, Camilla, so that's great. But typically, manufacturing applications don't really require the same types of speed as we see in piece picking or parcel handling. So can you just remind, for those who are looking, why this matters for manufacturing customers?
Many of our customers mount the Zivid camera onto a robot arm, which is a super alternative to mounting it statically above the scene. When you have that flexibility, you can get the camera up close to the objects you are looking at, giving you higher resolution and higher precision. When the Zivid 2+R is 3 times faster than before, it drastically reduces the amount of time the robot spends by stopping and imaging and starting again. This means that robot mounting becomes viable for more applications than before.
Great. All right, so that was a very impressive and difficult showcase of what the 2+R can do on challenging items. But I also happen to know that we actually have 26 customers that have challenged us to address even more extreme materials with even more reflections in them.
I know what you're talking about, David, and I have brought a bin here to illustrate this blue, shiny, terrible bin right here, filled with shiny things. I'm going to show you how this looks with our previous camera model, the Zivid 2 Plus M60. So if you start out by looking at the 2D image, you can see that this is almost like a mirror. You can clearly see the vertical reflections that are going to cause issues for the camera. And if we go into the point cloud, these 2 objects here, close to the bin wall, are just completely destroyed. You have this disc here, which would definitely not be recognizable by a CAD matching algorithm. Probably not the cylinder either, and even if it was recognized, this ghost plane here would stop the robot from picking or interacting with it. Reflections in general are a huge challenge in 3D imaging, and in particular, vertical reflections are almost impossible to solve for structured light cameras. I am therefore thrilled to show you our latest and greatest innovation, the Sage engine. Last year, we were the first to solve transparent surfaces with the Omni engine. Now we are doing it again, and we are the first to solve vertical reflections with the experimental new Sage engine. So let me show you what this looks like with the MR60 and the Sage engine. If we look at the point cloud now, the reflections are gone. This would be identifiable by a CAD matching algorithm, and this would not be hindering the robot from interacting with the object.
It's crazy to see how we can resolve these super hard reflections. But I also happen to know that the Sage engine is actually pretty good for something else as well. Because we do have a lot of customers that use, for example, hole detection to help their robots figure out what to do. For example, for solving ambiguous orientations or helping out with some alignment. So can you show what the Sage engine can do in this case?
Absolutely. I brought an example to illustrate this as well. So here I have a bin filled with shiny materials which have very fine details. This disc, for instance, you would only be able to determine the orientation of if you were to detect these little screw holes and alignment holes on its interior. We also brought some screws, which often the robot wants to pick up and identify as screws.
Yep.
I'll show you how this point cloud looks with the Sage engine because it can definitely help you here.
All right.
As the Sage engine is extremely conservative about what points it leaves and recognizes as valid points, you can get very fine details with high confidence. Here you can see that you would be able to recognize holes on this object and also on this one. And you can even see the threads on the screws over here. Yeah, so this is a very nice point cloud, just beautiful.
Wow, that's really incredible, Camilla. So to see what you guys have been able to achieve and the kind of quality and speed improvements that you've been able to do on top of this hardware is just remarkable. Next up, we're going to head over to Sam, who's going to show us how we're doing on the 2D camera side and what we did there for the 2+R. So thank you, Camilla.
Thank you, Øyvind.